Hello everyone, welcome to this video. Here we are going to see how exactly 8085 microprocessor look like and whenever you are using it, how you will be using it and what are the components in it. Okay, first of all, if you see there are so many microchips here and do not bother about this one. Now coming to the operation of this microprocessor, you have got two displays. This is display number one. Okay. This is display number one and this is display number two. This display number one is having four digits and display number two is having two digits. This is for address and this is for opcodes. Okay. All the opcodes are of two hexadecimal numbers, and if you see this one, this is of four hexadecimal number. Now coming to the keys, if you see this is actually a hexadecimal keyboard. It is having total 16 keys from 0 to F. 0, 1, 2, 3, 4, 5, 6, 7 and so on till F. And these are some functionalities. On clicking this, you can actually execute, reset the 8085 microprocessor, or execute or shift from this display to this display and so on. Now we'll go for the actual simulator because having this kit is bit costly, and that's why I have built a simulator which you can use and do the same operations that you want. Okay, now this is the link where you need to go to access this particular simulator. I'll post this in the video description. You will be able to see this kind of interface. This is actually in the simulator tab, and it is going to have two display inputs. One is address display and another is a opcode display. Okay, and there are 16 input keys which are all hexadecimal numbers, and there are some functionalities that we are going to use to execute our code. For example, if you look at this, this is our execution button. This is for shifting the display from this to this. It is an increment, decrement, and whenever execution is going on, if you click on this, it will break the execution. If you want to run the code step by step, you can use this button. And that's all what is required for execution. Okay, now we'll come to the now if you click on this help, you'll be able to see this one. Means there are some instructions how you can use this particular simulator, and if you are watching this video, I think this is not required because we are going to see an example and execute the code and see the output. This is the first program that we are going to solve. This is adding of two numbers. They have given us two numbers, 04 and 05, and the result of adding these numbers should be stored in 8000. In our simulator, we will be able to see the whole memory, and we'll also be able to see how the values in the registers are being changed. This is the actually an advantage whenever you are using a simulator. If you are using a kit, it will be difficult. I think it will be difficult to see the whole memory because you need to enter the address of each and every byte and check what is the value in that, and finding the value of register is also difficult. Now before going to a simulator, let's analyze this question and write the opcodes that are required. We'll go to our simulator. here we have got opcodes. Just drag and drop it somewhere in the new tab. You will be able to see this one. Now what you need to do, whenever you are adding two numbers, you cannot add directly. First you need to store these values in some registers. Actually this is a easiest way of adding two numbers. So first I'm going to store this 4 in accumulator. Okay, so I am going to use mv mvi. If you see this one, move immediate to accumulator, the value immediate value 8-bit immediate value should be moved to accumulator A. For that opcode is 3E. Therefore for doing this operation I am going to use 3E opcode, and then the value that I need to store is 4. This is actually a 8-bit code. Okay, 8-byte code. And now coming to the second operation. Now I'm going to store this 5 in register B. So if you look at this one, what this do, move immediate value to register B. Whatever you are going to enter after this one, after 06, will be stored in B. So if you take the opcode, that is 06 and then the value 05. After this you need to add. For adding, now see, the value of value 04 is stored in A, right, and 05 is stored in B. Now I need to add the value of B into A and store that value in A. Whatever we have got the result, that should be stored. It means 9 should be stored in A. For that we'll search for a opcode. Just enter add B. It means add register B to accumulator, right? And the code is 80. So we'll be writing, we'll not take this one. When you write 80, automatically the value will be added to the accumulator and it will be stored in accumulator. And after that we need to move the accumulator value to the memory, sta, and then enter address. For that we are going to use 32. We are going to use 32 and then enter address. Remember, while entering the address, we'll be writing it in the reverse order, 0080. Okay. And after writing all this, you need to enter 76 to make sure that your code will hold. Okay. Now let's start using our simulator. Come to the simulator. See, I have told that this is actually a address, and here you will be entering the opcode. Okay, now if I enter this one, it will automatically switch the displays. Now you can start writing the code from anywhere. I'll be writing the code from 0 1 0 0. I'll be writing the code from 0 1 0 0 and come to the opcode display. Here enter the first code that you have got, 3E, right? Enter 3E, and to go to the next address you need to enter this one, increment address. Automatically it will increment, it will read here. We have got 0 0 in the address, so write the value 04. 04. Again increment, go to the next opcode, that is 06, then increment, then 05. Okay, then increment, then go to next. This code will add the content of B to A and store it in B. So if I write 80, automatically it is going to store the value. And now go to the next opcode, that is 32. 32 will ask for a address after this, so that is 8000. This is 8000. So we are going to enter 00 increment 80 and increment. At the end we are going to have 76. This is halt. When the 76 is executed, actually the code stops. Now when you have entered, you can click on reset. You will come to this display, and let's check whether any value is stored in 8000 or not. Just type here 8000. So there is nothing in the 8000. Now let's execute our code. For executing, you need to go to the address 0100. This was the starting address that we entered. You can see here clearly it is 3E. Now if I click on execute, in the opcode display you can see exec. Now I start executing exec, and now execution stopped. Now let's see what is the value in the 8000. 8000. You can see we have got 800. It means we have successfully executed the given code. And if you see the register values, you will be able to see 9 is stored in A. We have got B in B we have got 5. Okay. And you can also see in the memory. If you load the memory, please wait. When you load the memory, you will be able to see the entered code here 01003E 010104. In this way you will have got your own code. Okay, till here only this is the code that we have entered. Okay, and if you want to execute step by step and see the changes that are taking place, just reduce the size of the window. Okay, and go to the starting. Okay, it is 0100, right? Go to the starting opcode, that is 3E. Now let's reset. Okay, on resetting we have got value as 00 and this has gone to 00. Reset will not delete the code that is there in the memory. Okay, don't worry about that. So 0100 we got 3E. Now on executing this 3E, you should make sure that 04 is stored in this one. Let's see, 04 stored in accumulator, right? Now again going to the next one, next step. See, 05 is stored in B, right? Now on clicking the next step, you should add these both and get that value in A, right? So step, we have got 9, and at the end enter again step, it will come to 76. It means it has moved the value to the 8000 address, and then step. This will halt our execution. Okay, I hope this was clear, and we'll go for the next program in the next video. Thank you.